Picture a civilization so ancient that no library holds its name, no stone tablet, no crumbling manuscript, no half-buried column rising from desert sand. Just a planet. Cold now, quiet now, with a sky the colour of a faded bruise and dust that hasn't stopped moving in billions of years. That's Mars. A world that most of us walk past in the night sky without a second thought. A dim, rusty dot between Jupiter and the Moon. And yet, what if that dot was first? What if, long before anyone scratched a drawing into a cave wall in southern France, before the first fire was kindled on the African savannah, before Earth had anything resembling a human being walking upright across its surface, something else was already happening up there, a civilization, perhaps tentative, perhaps extraordinary, perhaps so far removed from what we understand as history that we barely have the language to ask the question properly. That's where we're starting tonight. I'm Max, and welcome back to my channel, where we take the strange, the forgotten, and the genuinely fascinating corners of the past and turn them into something worth staying up for, or drifting off to, depending on where you are right now. Speaking of which, I'd love to know. Drop a comment and tell me where you're listening from and what time it is there. There's something quietly wonderful about knowing that someone in Auckland and someone in Oslo and someone lying in the dark in Sao Paulo are all sitting with the same strange question at once. And the question tonight is this: what if Mars was humanity's first home? What if Earth wasn't the beginning of our story, but a second attempt? A reset, a long migration across the void from one dying world to a living one. We're not here to claim certainty. Science doesn't offer that yet, and honest curiosity shouldn't demand it. What we're going to do instead is follow the clues, sit with the possibilities and let the imagination go somewhere it rarely gets permission to go, into deep time, into two worlds, into a history that may or may not have happened, but feels worth exploring anyway. There's a reason Mars isn't Venus. Think about that for a second. Venus is closer to us. Venus is nearly the same size as Earth. In terms of raw geography, Venus should be the obvious candidate for neighbouring life, the planet we look at first when we start asking whether we're alone. And yet nobody grew up reading science fiction novels about sultry Venusian empires the way they did about Martian ones. Nobody named their planet of ancient mystery after the second orbit. It was always Mars. It was almost inevitably Mars. Part of that is simply what the planet looks like from a field, from a rooftop, from the deck of a ship on a dark ocean. Mars is visible. It moves. It has a colour that nothing else in the sky quite matches, that deep reddish amber that ancient people noticed long before they had telescopes, or the faintest idea what a planet actually was. The Babylonians called it Nergal, their god of war and plague. The Egyptians tracked its retrograde motion with careful attention. The Greeks named it Ares. The Romans renamed it Mars. Every major civilization that ever stared upward long enough found Mars staring back. There's something in that colour, something that reads, even now, as alive in a way that a cold blue pinpoint of light simply doesn't. Then came the telescopes, and this is where the story gets genuinely interesting, because for a brief and extraordinary period in the late 19th and early 20th centuries, science seemed to be inching toward confirming what imagination had already decided. Giovanni Schiaparelli, an Italian astronomer, reported seeing what he called canali on the Martian surface. The word meant channels, natural formations, he supposed, but the word got translated into English as canals, and canals meant something entirely different. Canals meant engineering. Canals meant intention. Canals meant someone had been there with a plan. Percival Lowell, a wealthy American with a telescope and an almost heroic willingness to believe, ran with that translation and never let go. He mapped the canals. He wrote books about them. He argued with considerable public enthusiasm that Mars was a dying world, its water receding, its civilization frantically engineering survival by channeling polar ice toward the equator. It was a story of a society at the edge, working harder and harder against impossible odds. It captured the late Victorian imagination completely, and it laid the groundwork for almost everything that followed. H.G. Wells wrote his Martians as invaders fleeing exactly that kind of slow planetary death. Edgar Rice Burroughs sent his hero John Carter to a world of ancient dried ocean beds and crumbling cities. Ray Bradbury described Martian towns with a sadness so particular it felt like memory rather than invention. The canals turned out to be an optical illusion. The human eye, straining at the edge of resolution, connects dots into lines that aren't there. Lowell's maps were the product of wishful seeing more than disciplined observation, and yet the feeling those maps produced, that sense of looking at a world that had once held something and lost it, never quite left the culture. It had taken root too deeply. Here's why it feels emotionally compelling in a way that's hard to shake even now. Mars and Earth have things in common that Venus simply doesn't. A day on Mars is 24 hours and 37 minutes, close enough that you could almost keep your routine. Mars has seasons because it has axial tilt like ours. It has polar ice caps. It has what appear to be ancient river valleys, dried lake beds, geological formations that whisper of a wetter, warmer past. If you put a photograph of a Martian landscape in front of someone who'd never seen it and told them it was the Atacama Desert on a bad day, they might believe you. The scale is different. The sky is wrong. But the bones of it, the rocks and the dust and the plains, feel like somewhere a person might theoretically stand. That familiarity is what makes the first civilization idea do something to you in the chest rather than just the head. It's not pure abstraction, it's close enough to be personal. But here's where we need to take a breath and be honest about what kind of conversation we're actually having. Because there are three different things happening whenever Mars and civilization appear in the same sentence, and they're worth keeping separate. There's scientific possibility, which is a genuine, ongoing, active field of inquiry. Scientists do study whether Mars had the conditions for microbial life. They do take that question seriously. The question of complex life is far more contested and far more speculative, but it isn't dismissed by serious people the way it was a generation ago. There's cultural fascination, which is centuries old at this point, and has produced some of the most enduring stories in human mythology and fiction. That fascination is real and worth examining in its own right, because what we project onto Mars says as much about us as it does about the planet. And then there's the thought experiment, which is where we're spending most of our time tonight. A thought experiment isn't a claim. It's a what if, held carefully, followed seriously, and eventually set down without demanding that it be true. We're going to follow the idea of a Martian civilization, not because the evidence says it happened, but because the exercise of imagining it reveals things about deep time, planetary science, and the nature of civilization itself that are genuinely worth understanding. So consider the boundaries set, consider the telescope pointed, consider the canals, real or imagined, shimmering at the edge of what's possible. Because now we can ask the next question, which is what Mars was actually like, billions of years ago, when the possibility of something living and thinking was not quite so absurd as it might seem tonight. Picture Mars not as it is tonight, but as it was roughly 3 to 4 billion years ago. Not rust-red and desolate, not thin-aired and frozen. Picture it with clouds, picture it with rain. The evidence for this isn't speculation dressed up as science. It's written into the planet's surface, in a language geologists have spent decades learning to read. There are river valleys on Mars, ancient and enormous, carved in a style that only moving liquid water produces over long periods of time. There are lake basins, some of them hundreds of kilometers across, with shoreline features that match what you'd expect if a body of water sat there long enough to leave a mark. There are minerals, phyllosilicates and carbonates and sulfates that form in the presence of water and essentially cannot form without it. Curiosity and perseverance have been driving across these formations for years now, rolling over the floor of what was almost certainly once a lake bed. Jezero Crater, where Perseverance landed, was chosen precisely because the scientists believed they were sending a robot into a place that once held standing water. Not as a long shot, as a reasonable bet. The atmosphere was different too, thicker, warmer. Mars today has an atmospheric pressure roughly 1% of Earth's, barely enough to register, too thin to hold liquid water on the surface without it boiling away almost immediately. But early Mars seems to have held a more substantial blanket of gas around itself. Not Earth-thick, perhaps, and scientists argue about the precise density, but enough to trap some heat, enough to allow the kind of surface conditions where water didn't simply vanish the moment it appeared. There was a magnetic field once as well, shielding the surface from the worst of the solar wind, the same relentless particle stream that eventually stripped so much of that atmosphere away when the field collapsed somewhere around 4 billion years ago. Now compare that to early Earth. Early Earth was not a paradise either. It was volcanic, heavily bombarded by asteroids, its atmosphere mostly carbon dioxide and methane, and very little of the oxygen we take entirely for granted. And yet something happened here. Chemistry organized itself into biology. Biology grew more complex. Eventually, improbably, it produced creatures that could sit and wonder how it all began. The conditions that allowed that to happen were not gentle. They were harsh and chaotic, and frequently catastrophic. But they were present. The window of habitability on early Mars, rough and uncertain as our reconstruction of it is, seems to have overlapped with a period when the same basic chemistry might have had a chance. Liquid water, some atmosphere, energy sources from volcanic activity and sunlight, the ingredients that, on Earth, eventually produced everything. The timeline is different, the details are different, and most scientists would remind you quickly that the gap between microbial chemistry and intelligent civilization is so vast it barely fits inside a human imagination. But the question of whether that early Martian window was long enough, stable enough, and chemically rich enough to produce not just life, but complex life, that question doesn't have a clean answer yet. And this is where intellectual honesty has to enter the room. Because we are reconstructing Mars's deep past from incomplete data, rover tracks through a fraction of the surface, orbital imaging with resolution limits, atmospheric models built on assumptions that may shift as we learn more. We don't know exactly how long the wet period lasted. Some researchers think it was billions of years of episodic habitability. Others argue it was geologically brief, millions of years rather than billions, which changes the calculation considerably. We don't know how thick the early atmosphere truly was. We don't know with certainty what happened to the water, how much was lost to space, and how much lies frozen underground. Every answer so far has arrived carrying 3 new questions behind it. What we can say, with some confidence, is that the early Mars and the early Earth were not the radically different worlds they are today. The gulf between them in that ancient era was narrower. Earth had advantages, more mass, more internal heat retained longer, a larger moon that stabilized its tilt, a position in the solar system that kept it in the habitable zone even as the sun slowly brightened. Mars was always smaller, always working with less, always closer to the edge of what was survivable. But closer to the edge is not the same as over it. For life to have a chance at complexity, let alone something approaching intelligence, you need time above almost everything else. Time for simple chemistry to become biology. Time for biology to diversify. Time for the kind of evolutionary pressure that eventually, on one world at least, produced something that built tools and language and cities. Whether Mars had enough of that time is the question sitting quietly at the centre of everything that follows. Because if it did, even theoretically, even in the most generous reading of the evidence, then the thought experiment stops being a fantasy and starts being something stranger and more interesting. It starts being a possibility you can't entirely dismiss. So let's take that possibility and treat it the way a careful historian treats a rumour in an old archive. Not as a fact, not as a fairy tale either, as something you handle gently and only move forward when the next step still makes sense. Because the jump from wet Mars to thinking Mars is not one jump. It's a long chain of small stubborn links. On Earth, life appears early in the record, at least as far back as we can confidently trace. Single cells first, then for a very long time, only single cells. Microbes that divided and ate and drifted and endured, while entire continents were rearranged above them. Then more complexity. Cells that learn to cooperate instead of simply competing. Bodies made of many parts. And only much later, after more false starts than we can count. Nervous systems, eyes, behaviours, learning, memory. And after all of that, after billions of years of chemistry and competition and chance, you finally get something that can reshape its environment on purpose. A technological society. Not just intelligence, but intelligence that accumulates. That stores knowledge. That passes it on reliably enough that one generation doesn't have to start from scratch. If you imagine that chain laid out like a road, habitability is only the first mile marker. It tells you the road exists. It doesn't tell you where it leads. Now ask the Martian version of that question. Did Mars have enough road? Enough time? Enough stability? Enough continuity to let those links form before the planet cooled? The magnetic shield weakened, the atmosphere thinned, and the surface became the dry, irradiated place we see today. The honest answer is maybe, but the margins are tight. Mars is smaller. That matters in the unromantic way physics always matters. Smaller planets lose heat faster. Their interiors slow down sooner. Volcanism declines. Recycling of the crust becomes sluggish or stops. And without a churning interior, you don't just lose spectacular eruptions, you lose the long-term planetary metabolism that helps keep an atmosphere supplied and a climate buffered. And time is everything here. On Earth, complex life didn't rush in. It took its time to appear, and then, once it appeared, it still took its time to become elaborate. If Mars's most habitable era was short, if it was a few 100 million years of favourable conditions punctuated by long cold spells, then life might have had a chance to begin, but not necessarily to climb. There are bottlenecks in evolution that don't care how pretty the landscape is. The first is simply getting started, assembling self-replicating systems that can persist. The next is surviving long enough to diversify without being wiped back to the beginning. Another bottleneck is the move to complex cells with internal structures. On Earth, that jump is profound, and it seems to have happened only once. Another bottleneck is multicellularity. Another is large bodies with active metabolisms. Another is something like a brain capable of planning and abstraction. None of those outcomes is automatic. Earth is not a conveyor belt that guarantees cities at the end. Earth is one data point. And even on Earth, if you replayed the tape, there's no promise you would get the same ending. Mars would have had its own hazards too. A thinner atmosphere, even when it was thicker than today, means less protection from radiation and impacts. Lower gravity means the planet holds onto gases less tightly over time. It also changes how air and water behave, how weather works, how easily an ecosystem can maintain stable conditions. And because Mars sits farther from the Sun, the baseline is colder. That means the planet's habitable zones, if they existed, may have been patchier, oases rather than oceans, basins and valleys where water lingered, with long stretches of marginal terrain between them. That kind of world can still host life, but it can also keep life constrained. If ecosystems are fragmented, evolution can become a series of isolated experiments, brilliant in their own corners, but less likely to build the global, interconnected complexity that, on Earth, seems to have helped life push into new levels. And then there's catastrophe. On Earth, mass extinctions reset the board. On Mars, the slow catastrophe may have been the planet itself, the gradual loss of shielding, the gradual loss of air, the steady drying and freezing of the surface. A civilization doesn't just need to arise, it needs time to arise before the lights start going out. Still, it's worth noticing something. A planet doesn't need to be perfect everywhere to produce something remarkable somewhere. If there were long-lived lakes, if there were stable coastlines, if there were regions with geothermal warmth and chemical gradients, places where energy was abundant and consistent, then you could imagine a long, patient evolutionary story playing out in those refugees, while the rest of the planet drifted toward harsher conditions. And if intelligence did emerge in such a world, it might not look like the kind of intelligence we instinctively picture. We tend to imagine Martians as basically us with different skin. That's lazy storytelling. A Martian civilization, if it existed, would be shaped by constraints that are not decorative details, but daily realities. Lower gravity changes architecture and physiology. Tall structures are easier. Heavy lifting is cheaper. Bodies could be more delicate, or at least differently proportioned, because bones and muscles don't have to fight as hard against collapse. But lower gravity also affects pregnancy, circulation, long-term health, the entire engineering of living tissue. It doesn't just make you bouncy, it rewrites what strong means. Colder conditions make energy central. Heat becomes as important as food. You don't build sprawling open-air cities if the air bites you most of the year. You build inward, underground, insulated. You cluster near warmth, sun traps, geothermal vents, volcanic provinces. You treat a sealed habitat not as an emergency measure, but as normal life. Scarce resources shape technology too. Mars lacks the easy abundance of accessible biomass and forests that helped humans smelt metals and build early industry. If oxygen is limited, fire behaves differently. If surface organics are scarce, you don't get the same straightforward ladder from campfire to furnace to factory. A Martian technological path might lean early on electricity from chemical gradients, on careful recycling, on ceramics and composites, on using sunlight aggressively whenever the sky allowed it. And water, if it became precious, would become sacred in the most practical sense. A civilization raised on the edge of dehydration learns thrift as a form of morality. It learns to count what it cannot afford to waste. Even its myths would probably be written in that language. The story of warmth, the story of shelter, the story of stored air and stored water, and the thin margin between survival and loss. But all of this is still only a sketch made from constraints. It's a historian's what would have to be true, not proof that it was true, because the biggest obstacle to a Martian first civilization is not that it's impossible, it's that it's demanding. It asks for a world that stayed kind long enough to let complexity bloom, and then stayed stable long enough to let intelligence not only appear, but build continuity, libraries, learning, institutions, something that persists across generations. On Earth, even with a thick atmosphere, a strong magnetic field, oceans that act like climate stabilizers, and a planet-sized engine still running hot, it took an astonishingly long time. And even then, technological civilization is young, so young that if you compressed Earth's history into a single day, our era would be the last flicker before midnight. So could intelligence have risen on Mars first? If you want an answer that respects what we know, it sounds like this. It's not ruled out by the existence of ancient water and a thicker atmosphere. It's not guaranteed by them either. Mars may have had a window, and windows can be generous or narrow depending on where you stand. What we have is a planet that once looked capable of hosting life, and a universe that has already surprised us by producing life at least once. Somewhere between those two facts the mind starts to wander, and it wanders for a reason. Because if Mars did manage even the early steps, if it became not just habitable, but inhabited, then the next question arrives naturally, almost quietly. Not whether life was possible there, but whether life, once started, had time to become something that could look back at the sky and wonder if it was alone, And if something on Mars could look back at the sky and wonder, then sooner or later it would have noticed another thing. The sky itself was changing, not in the dramatic way stories like to tell it, not a single day when the air vanished and the seas boiled off, and everyone stood in the streets and pointed, more like a long, slow leaking, a planet that used to hold on, gradually letting go. Mars is small and the sun is not gentle. Over time, solar wind can strip away the upper atmosphere, especially if a planet's magnetic field is weak or fading. Think of it like a coat that keeps getting tugged at, thread by thread, until it no longer does its job. Less air means less pressure. Less pressure means liquid water becomes harder to keep on the surface. Less water means less weathering and less cycling of carbon. Less cycling means the climate loses its ability to correct itself. It's a chain reaction, but it happens at the speed of geology, which is to say, too slow to panic about at first and too persistent to ignore forever. As the atmosphere thins, the planet cools. Some of that is simple distance from the sun. Some of it is because greenhouse gases don't build up as easily. And some of it is because, once Mars's interior quiets down, there's less volcanic activity to replenish what's lost. The heat engine slows. The surface becomes less dynamic. The planet starts to feel older than its age. Then comes radiation. A thick atmosphere and a strong magnetic field are like an umbrella and a roof. They don't stop every raindrop, but they turn a downpour into a manageable drizzle. Take them away, and the surface becomes a harsher place to be alive, especially for complex life. Over long timescales, radiation doesn't just threaten bodies. It breaks down organics. It damages DNA. It makes the open ground less welcoming for anything that depends on stable chemistry. And water, the oldest requirement, becomes the most fragile. On a cooling Mars with falling pressure, water retreats. It hides. It locks itself into ice. It sinks underground, if there's anywhere porous enough to hold it. What was once a network of lakes and rivers becomes seasonal melt, then rare melt, then only the memory of melt. You can still have brines, you can still have salty pockets that stay liquid for a while, but the easy water, the water that runs and fills and renews, becomes scarce. Now imagine living through that as a civilization. Picture the largest city on Earth. Now imagine it built beside the last dependable river on an entire planet. Add reservoirs carved like cathedrals underground. Add rationing so normal that children learn it before they learn poetry. Add laws about recycling that are treated the way we treat laws about murder. Not because the leaders are tyrants, but because the environment is. A slow planetary crisis doesn't arrive like an invading army. It arrives like accounting. Year after year, the same systems cost a little more to maintain. The same harvests become slightly less reliable. The same storms carry a little more dust and a little less rain. The same wells need to be drilled deeper. The same domes need thicker shielding. The same medicines fail a little faster because supply chains break down when they have to cross empty, cold distances. At first, a smart society adapts. It builds better seals, better storage. It learns to hoard heat the way ancient humans hoarded grain. It becomes fanatically good at closing loops, recycling water, reclaiming air, turning waste into feedstock again and again until almost nothing is wasted. And that kind of adaptation shapes you. It doesn't just change technology, it changes manners, morals, and memory. A people raised in abundance tend to tell heroic stories about conquest and expansion. A people raised in scarcity tend to tell stories about cleverness, restraint, and the terrible consequences of pride. Their myths would not just celebrate rain, they would mourn it. Their calendars might mark not only seasons, but the historical shrinking of seasons. How long the thaw lasts now compared to how long it lasted when their grandparents were young. They might develop a culture that treats the surface the way we treat the open ocean. Beautiful, dangerous, and not really meant for permanent living. So the first response to a failing Mars might be retreat. not as surrender, as strategy. If the surface becomes too cold, too dry, too irradiated, you go where the temperature is steady. Underground, rock becomes insulation, lava tubes become streets, caverns become plazas. You can bury water storage under meters of shielding. You can build farms under lamps. You can keep a breathable atmosphere from bleeding away into the sky. In that world, home might not mean a house with a view. It might mean a pressure door that always closes, a wall that always holds, a system that always cycles. Comfort would be the quiet hum of machines that keep you alive. The most beautiful sound might be nothing at all, the absence of leaks. But there's another response too, and it's the one civilizations often choose when they feel the walls moving in. Desperate innovation. When survival becomes a design problem, you start designing things that would have looked like madness in an earlier age. Planetary engineering, perhaps, trying to thicken the atmosphere by releasing gases from rocks and ice, trying to warm the surface with engineered greenhouse effects, trying to shade or shield regions from solar wind, trying to restart a stalled world with technology. And that's where we have to add a second kind of failure, because even if the planet is declining naturally, a civilization can still make its own situation worse. Resource overuse doesn't require malice. It only requires urgency. If water is shrinking, you may drain aquifers faster than they can recharge. If fuel is scarce, you may strip the last accessible deposits and leave behind poisoned ground. If you need heat, you may burn through chemical resources that took eons to accumulate. You may mine too aggressively, destabilize tunnels, collapse habitats. You may overbuild life support systems that are efficient but brittle, perfect in the lab, catastrophic in the real world. And then there's conflict. When the livable zones shrink, politics becomes geography. City-states become water rights treaties. Borders become lines around reservoirs. The same instincts that make humans fight over rivers would not be unique to Earth. If anything, they'd be sharpened on Mars. The stakes would be literal breath. Some factions might argue for strict conservation, for retreat and stability. Others might argue for expansion, claim new ground, dig deeper, build bigger shields, take what you can before it's gone. Some might bet everything on terraforming, on forcing the planet back into habitability. And some might say, quietly at first, that the real solution is not to fix Mars, it's to leave. That idea wouldn't appear as an adventure. It would appear as a grief. Because leaving is admitting something about your world, that it is not just sick, but dying. And a slow planetary death does strange things to the way a society thinks about time. You stop assuming the future will be bigger than the past. You start planning in reverse. How to preserve, how to archive, how to compress a civilization into something that can travel. In a culture like that, history would become practical, not a hobby, a lifeline. What do you take with you when you can't take your world? What knowledge is essential? What art matters enough to carry? What languages do you preserve? What seeds, what microbes, what carefully engineered ecosystems do you pack into vaults like treasure? And maybe, after generations of retreat and repair and argument, the conclusion hardens into a final project. Not extinction, migration. Not a dramatic last stand under a red sky, but a planned, institutional effort. Shipyards that are really life support factories. Schools that teach orbital mechanics the way we teach reading. Religions that promise not heaven, but another coastline under another sun. Because if Mars was once kinder and then became cruel, a smart species would eventually understand the pattern. The planet is not punishing you. It is simply following its physics. And physics doesn't negotiate. So perhaps the most Martian response, patient, engineered, unsentimental, would be to treat survival the way engineers treat any problem. Define the constraints, accept what cannot be changed, and if the environment cannot be made to fit you anymore, then you go find an environment that can. And that's where the story tilts, almost without you noticing. Because once you allow for the possibility of a Martian civilization facing a long decline, You also allow for the possibility that their end was not a silent planet. It was a departure. Departure sounds clean when you say it that way. Like a ship leaving a harbour, like a choice made with confidence. But between deciding to leave and actually arriving somewhere else, there's the hardest part of the story. The journey. So let's ask the quiet, inconvenient question. If a civilization on Mars was dying, could it realistically send anything to Earth? Not a fairy tale, not a poetic spark of life, but something that counts. People, embryos, knowledge, machines. Anything that could restart a world. Because there are strong, simple alternatives that don't require much romance. Seeding life, for example. If Mars had microbes and Earth was young, impacts could swap rocks between planets. We know meteorites from Mars reach Earth even now. It's not controversial, it's physics, and it happens whether anyone wants it or not. That kind of transfer is the weakest version of our story. It doesn't need a civilization. It doesn't need intention. It's just stones thrown by chance, carrying chemistry in their cracks. Then there's the slightly stronger version. Automated probes. Machines that don't eat, don't panic, don't need air. If you can build a probe, you don't need to solve all the problems of interplanetary immigration. You only need to solve guidance, power, and survival through time. You can send instructions. You can send libraries. You can send a toolkit for rebuilding. And stronger still is directed seeding, panspermia with a steering wheel. Not random rocks, but capsules designed to survive entry, carrying microbes, algae, maybe frozen embryos, maybe engineered organisms, meant to prepare a planet like gardeners preparing soil. All of those options have one thing in common. They avoid the hardest cargo of all, a living adult population. Because sending people is not just propulsion, it's ecology, it's politics, it's medicine, it's psychology. It's a small world sealed inside a shell, where one bad decision isn't just inconvenient, it's fatal. And yet, if Mars was truly failing, you can imagine why they might still try. If your atmosphere is leaking away, you have time, but not infinite time. You can build underground, you can ration, you can become brilliant at recycling, but you can't recycle sunlight into a magnetic field. You can't legislate your way out of a planet's mass. So suppose the decision to leave becomes a long, institutional project, not a last-minute rocket on a launch pad. More like the building of cathedrals, measured in generations. And in that case, the first thing to ask isn't, could they go? It's, could they reach orbit? Because orbit is the real border. Once you can reliably put payloads into space, again and again, you can do the rest slowly. You can assemble ships in pieces. You can stockpile fuel in depots. You can practice, fail, and practice again without losing everything in one launch. Mars actually makes that first step easier in one important way. Lower gravity and thinner air mean you need less energy to get off the ground. A species with decent chemistry and decent engineering would find Mars a more forgiving launch site than Earth. But that's also where the prehistoric or lost civilization framing becomes tricky. If we're imagining something so ancient that all traces are gone, then what level of technology are we allowed to grant them? Interplanetary travel doesn't require magic, but it does require precision. You need materials that can handle heat. You need fuels with high energy density, or systems that can work around that. Staged rockets, nuclear thermal engines, maybe even solar sails if you're patient. You need navigation accurate enough to hit a moving target across tens of millions of kilometers, with a sun in the middle trying to complicate everything. And you need time, not just travel time, though that matters, but time to build the industry that makes launches routine. Mines, refineries, clean rooms, pressure-tested habitats, radiation shielding. You don't go to another planet with a single, brilliant invention. You go there with supply chains. So maybe the lost civilization isn't a Stone Age tribe carving rockets out of rock. Maybe it's something that reached high technology and then collapsed so thoroughly that later Mars, cold, dry, irradiated, became a kind of eraser. A world that doesn't recycle its surface the way Earth does. A world where ruins can sit for ages, until dust buries them and radiation and temperature swings chew them into nothing recognizable. Now consider the timing, because timing is everything in this kind of story. Earth wasn't always the friendly blue world we know. There's an early Earth that's violent, molten, still forming. There's an Earth choked with volcanic gases. There's an Earth before stable oceans, before a calm enough climate for complex ecosystems to take hold. There's an Earth that's habitable in the microbial sense, and an Earth that's habitable in the you could build a home here sense. If Mars is dying slowly, the window might be narrow. Earth becomes comfortably habitable, late enough that life can thrive, but early enough that Mars still has the industrial strength to launch missions. That overlap is the whole bridge between worlds, and it gets stranger, because a dying civilization might not aim for the Earth we would pick. They might aim for Earth as it was, warmer, wilder, perhaps less oxygenated, perhaps more unpredictable, but with something Mars was losing: thickness, pressure, protection, a sky that holds. A Martian expedition might not come as conquerors. It might come as refugees to a planet that still feels dangerous, but not terminal. A world with storms, yes, and microbes, yes, and oceans that don't care about you, but also a world that isn't bleeding into space. So what exactly do they send? If they send people, the mission becomes a multi-generational arc or a fast, risky sprint. A multi-generational arc requires stable, closed-loop life support for decades or centuries, plus social stability in a metal cylinder. That's not impossible in principle, but it's hard even for us to imagine doing well. You'd need a culture engineered for patience, for routine, for staying sane while your whole universe is a few rooms and a schedule. A fast mission reduces the social problem, but increases the engineering problem. Faster travel means more energy, more shielding, more risk. Radiation through interplanetary space isn't a myth, it's a quiet, constant stress. Without protection, it's like living under a sky that never stops throwing dice against your cells. Embryos are a clever compromise. You can pack thousands in a space smaller than a suitcase. You can protect them with mass. You can keep them cold, keep them dormant. Then you need machines to raise them, teach them, and keep them alive. An automated childhood for a species that arrives with no parents. That sounds chilling, but it's also practical. It's a way to move a civilization without moving a population. A way to move a library without moving a city. Or maybe they send only knowledge, probes with archives, instructions etched into durable materials, autonomous factories that can bootstrap industry from local resources. It's the least sentimental option. No bodies, no breathing, just the idea of a people preserved as information, like a message in a bottle tossed across a cosmic sea. And that brings us to the last question in this section, the one that haunts every version of the story. If any of this happened, where are the traces? You might expect obvious ruins on Earth. You might expect artifacts older than human history. You might expect something that doesn't fit. But Earth is a hungry planet. It has weather, it has oceans, it has tectonics, it has biology, which is its own kind of corrosion. Given enough time, Earth doesn't just bury things, it digests them. Mountains rise and fall, coastlines move, metal rusts, stone cracks, cities become soil. A landing site near an ancient shoreline could be underwater now. A settlement on a river plain could be under kilometres of sediment. Anything built of recognisable materials might have been recycled by later life, broken down, absorbed, repurposed, erased. And if the transfer was mostly machines and embryos, if it happened in a remote place, if it was small and careful, it might not leave a clear scar. It might leave only subtle fingerprints, odd distributions of elements, anomalies in isotopes, a mystery in genetics, a story in myth that sounds like metaphor, because that's the only language that survives. Or the traces could be on Mars instead. Launch facilities, deep vaults, starved cities underground. A final archive sealed behind doors that never reopened. But even Mars, for all its stillness, isn't a museum with perfect lighting. Dust buries, radiation scrambles, impacts crater, and a civilization leaving in pieces over centuries would tidy up, dismantle, salvage, reuse. The last age of a dying world is not wasteful. It is efficient. It burns its own past for fuel. So the journey from one world to another might not be a parade you can spot in the rocks. It might be more like a whisper carried across time, a deliberate act hidden inside natural processes, a plan disguised as accident, a civilization packing itself down to its essentials, compressing into seeds and code and machines, and then slipping away from a red planet that could no longer keep them. And if even one of those missions made it, if even one survived the cold crossing and the violent entry and the uncertain landing, then the most important part wouldn't be the launch, it would be what happened next. Because arriving is not the same as beginning. Beginning is a gentle word. It sounds like a sunrise, but for whoever arrives, people, embryos, machines, a library, in a capsule, it's more like waking up after a disaster and realizing the room is gone. Picture Mars as they knew it, if they ever had a they at all. Tight domes, underground halls, air you could measure, water you could account for down to the last litre. A world where every breath had a cost and every careless leak was a crisis. Now put them on Earth, not the Earth of postcards. Early Earth, loud with weather, thick with oceans, crowded with life that doesn't ask permission. A sky that presses down with comforting weight and unfamiliar chemistry. Gravity that feels like a judgment. A planet that doesn't need you to maintain it. And that, strangely, might be the hardest part. Because on Mars, survival would have been deliberate. On Earth, survival could become impulsive. You can step outside without a suit. You can drink from a stream, at least until it makes you sick. You can burn wood instead of rationing oxygen. You can lose things and not die for it immediately. So if Earth was the second attempt, the first challenge wouldn't be building a city. It would be resisting the urge to relax. You can imagine the first settlements not as shining outposts, but as nervous little knots of order on the edge of too much. A few shelters, a greenhouse, a fenced boundary, not because Earth is empty, but because it's alive. Earth has teeth, just not always the kind you can see, and you can imagine the rules they'd bring with them. Rationing, even when the forest looks endless. Recycling, even when rivers keep flowing. Planning for failure as a habit, because Mars would have trained them to think in worst cases. On a dying world, optimism is expensive. You don't spend it lightly. But memory is also expensive. It takes work to carry it across generations. If the transfer was small, if the landing was harsh, if the survivors were few, or if the first humans here were raised by machines with only a curriculum and no grandparents, then the story of Mars wouldn't stay crisp. It would soften at the edges. It would become less like history and more like weather, something you feel, not something you can prove. Picture a child on early Earth, staring at the night sky. They're told, "We came from there." At first it's a fact, then it's a lesson. Then it becomes a proverb about exile. Then it becomes a sacred place where the ancestors went when they died. Mars is already the colour of blood. It already looks like a wound in the sky. It doesn't need much help becoming a symbol. And once a true story becomes a symbol, it can split into many smaller stories without anyone noticing. A collapse becomes a flood. A failing atmosphere becomes a thief god who stole the air. An ark becomes a serpent, a boat, a basket, a mountain refuge. A sealed habitat becomes a garden. A controlled environment becomes paradise. That's the way myths work. They aren't lies, they're memories that learned how to survive. So in this second attempt world, you could imagine why so many human traditions cling to the idea of a lost golden age. Not just nostalgia, but a warning. Not just, we used to be better, but we used to have more, and we wasted it. And you could imagine why sky gods appear so easily. If your ancestors truly did fall from the heavens, if the earliest teachers arrived in capsules and were tended by machines, then the line between technology and divinity would be thin as paper. A device that speaks, that heals, that glows, that predicts the seasons, is not advanced to a people starting from scratch. It is simply beyond the world. Sacred knowledge, then, wouldn't be superstition. It would be a locked drawer. What do you preserve when you're rebuilding from near zero? Not everything. Not art, not philosophy, not the full complexity of a lost science. You preserve what keeps children alive. How to make safe water, how to store grain, how to predict weather, how to avoid poisonous plants, how to treat infection, how to make fire without burning down the shelter. Over time, those practical instructions can become rituals, because rituals are how societies keep important behaviours from drifting. You don't merely remember to do it, you do it the same way, every time, because the old way worked, and that's where agriculture takes on a different flavour in this story. Mainstream archaeology explains farming as an earthborn transition, people domesticating plants and animals over long periods shaped by climate changes, population pressures, and local experiments. That explanation is strong, evidence-based, and it doesn't need Mars. But if we're daydreaming carefully, if we're treating this as a lens rather than a claim, then agriculture could look like something else too. Not a sudden gift from the stars, but a habit imported from necessity. On Mars, you don't hunt your dinner. You grow it, or you die. You live by schedules, by cycles, by controlled environments. So if descendants of a Martian collapse arrived on Earth, they might gravitate toward cultivation faster than a purely Earth-evolved culture would. Not because they're smarter, but because their instincts are trained. They might see the wilderness and feel uneasy. Too many variables, too many surprises. A field, on the other hand, is a piece of Mars you can recreate, a small patch of predictability, a promise you can measure. Settlements, too, might carry the shadow of the first planet. You could imagine early towns built with an odd emphasis on storage, on walls, on controlled access, not because Earth demanded it immediately, but because memory did. You build as if you might need to seal the doors. You keep emergency supplies. You watch the sky for omens that, in a distant past, weren't omens at all, but real measurements, pressure, radiation, dust. And the fears might be different. A species shaped by a planetary collapse would treat abundance with suspicion. It would treat waste as moral failure. It might develop taboos around air, water, fire, things that were fragile on Mars, even if they seemed generous on Earth. Ambition, too, could be haunted. If your deep cultural memory includes a world that reached high capability and still failed, then progress stops being a simple upward story. It becomes a loop you might repeat if you aren't careful. So perhaps early religion, through this lens, isn't only about explaining thunder. It's also about restraining people, about keeping a community from turning abundance into arrogance. Don't take too much. Don't anger the sky. Don't forget the old rules. Remember the fall. And yet, we should keep one foot on the ground, because Earth's archaeological record, as incomplete as it is, still tells a coherent story of human development rooted here. Stone tools evolving over time, migration patterns, domestication events traced through plant genetics, the slow rise of villages into cities. We have bones, seeds, pottery, hearths, ordinary things that make extraordinary history without needing a planetary prequel. So maybe the Mars story isn't something that happened. Maybe it's something that feels plausible because it matches our anxieties, that civilizations can collapse, that technology doesn't guarantee wisdom, that a home can become unlivable. But even as fiction, it offers a quiet way to reread the earliest chapters of our own world. Not as a simple tale of from caves to cities, but as a second chance story. As if the human heart arrives already carrying a lesson it can't quite articulate, only act out in myths, in rituals, in the stubborn decision to plant seeds and build walls and tell children over and over that once there was another place. A place that failed. A place still hanging in the night sky, small and red and easy to ignore. Unless you're the kind of species that can't stop looking up and wondering what it forgot. So if we let this idea breathe for a moment, If we treat it like a hypothesis instead of a bedtime myth, then the next question is not, wouldn't that be wild? The next question is quieter. What would it leave behind? Because civilizations, even careful ones, are messy. They shed things. They scar the ground. They rewrite chemistry. They leave fingerprints in places that don't care about stories. Start with the strongest evidence first, not vibes, not shapes in a blurry photo. The kind of evidence that makes arguments stop. Unmistakable artifacts. Not a rock that looks like a face, but a thing that cannot be made by geology. A wheel bored hole with tool marks. A piece of metal alloy that doesn't form naturally in that combination. A manufactured polymer or a ceramic with an engineered microstructure. A circuit-like pattern with repeated intentional geometry. Something with right angles so consistent you could bet your life on it. Better yet, a cluster of them. Because one strange object can be a fluke or a contamination or the universe playing a trick. A sight is harder to explain away. Then there are biosignatures, not fossils in the romantic sense, little fish pressed into stone, but chemical ghost stories. On Mars, the best ones would be patterns life tends to make, and non-life tends to struggle to imitate. Certain ratios of carbon isotopes, organic molecules arranged in ways that suggest selection and metabolism. Layers of minerals that look like they were laid down in the presence of biology. And if we're talking about a technological civilization, there's an even sharper category, technosignatures. Industrial chemistry can leave behind molecules that nature rarely produces, certain chlorinated compounds, persistent fluorinated substances, artificial isotopic ratios from nuclear processes, local spikes of elements used in electronics and industry, traces of mining that don't match natural erosion. Picture it like this. Take a calm lake on Earth and dump a city's worth of waste into it for centuries. Even after the buildings rot, the lake remembers. The mud keeps receipts. Mars doesn't have mud in the same way, not everywhere. It has dust, rock, and time. And time on Mars behaves differently than time here. There's no rainforest to chew ruins into soil. No plate tectonics to recycle a continent like a rough draft. No oceans constantly sanding the edges off your mistakes. In some ways, that makes Mars a better archive than Earth. In other ways, it makes it cruel, because Mars is also bombarded. Radiation, micrometeorites, abrasive dust storms, a slow, patient sandblaster. Organic molecules can be broken apart near the surface, scrambled until they're no longer readable. Whatever history is there might be hiding, not in open air, but under meters of regolith, tucked beneath ancient lava flows, sealed under ice. So what have we actually found? We've sent orbiters that can see the shapes of valleys and deltas, like old handwriting. We've sent rovers that crawl like cautious insects, tasting rocks, drilling shallow holes, taking selfies beside cliffs older than human imagination. They've found compelling things, ancient lake beds, minerals that form in water, clays, sulfates, river channels, even complex organic molecules in sedimentary rocks, important but not proof of cities, and methane that appears and disappears, teasing us with the possibility of geology or biology or both. But none of it so far is the signature of a technological society. No paved grids, no collapsed domes, no fields of debris that scream manufactured, no concentrated deposits of refined metals in patterns that look like extraction, no layers of ash and industrial soot spread around the planet at a particular date. That absence matters. It doesn't kill the idea, but it disciplines it. Because Mars is not unexplored anymore in the naive way it once was. We have mapped it, photographed it, measured it. And while we have not dug deep, we have looked enough to say, if there was a civilization like ours spread across the surface in big, obvious ways, it likely would have left more than whispers. So maybe the theory shifts, the way theories do when they meet data. Maybe any Martian civilization was small, concentrated, localized near water and geothermal heat. Maybe it lived underground, not as a sci-fi choice, but as the only practical way to survive radiation and cold. Maybe it died early, before it built continents of infrastructure. Maybe it used materials that don't preserve well, or it deliberately cleaned up, dismantled, recycled, or maybe it never existed at all. And then there's the other half of the question. If Earth was the second attempt, would Earth remember? Because Earth is a hungry planet. It eats its past. Picture a house built on a beach, tide after tide, storm after storm, until the foundation is gone and the sand looks innocent again. That's what Earth does to most evidence, given enough time. Wood rots, iron rusts, cities sink, rivers change course, glaciers grind landscapes into flour. Continents move, oceans rise. In a few million years, even mountains can be humbled into hills. So if a small group arrived here long ago, really long ago, what could they leave that would still be readable? Bones, maybe. But bones don't come with passports. A skeleton doesn't announce it was born under a different sky. Genetically, the clue would be subtle. Odd bottlenecks, strange divergences, a timeline that doesn't quite match. And yet, human genetics, as studied today, point strongly to an earthly ancestry with deep roots in Africa, branching and mixing in patterns that fit fossils and archaeology reasonably well. Not perfect, not finished, but coherent. Artifacts? Possible, but difficult. If early settlers lost technology quickly, their tools might look like the tools of any struggling people. Stone, bone, wood. If they kept some advanced pieces, those would be precious, guarded, reused until they vanished. A metal object can be melted down 100 times. Knowledge can survive without the original machine. This is where we need to separate three kinds of evidence, because they often get tangled together in the dark. First, intriguing anomalies. A strange rock formation, an out-of-place mineral. A pattern that makes you pause, useful as questions, not as conclusions. Second, misunderstood patterns. The human brain is a pattern engine. It will find faces in clouds and cities in shadows. On Mars especially, where lighting and erosion can sculpt the land into almost anything, it's easy to be fooled. A ridge looks like a wall until you see it from another angle. A tower becomes a hill. A road becomes a fracture line. Third, scientifically persuasive evidence. This is the boring kind, and boring is good. It comes with repeatability, context, and multiple lines of support. A mineral signature that matches a process. A sample with isotopes that tell a clear story. A site that can be mapped, dated, and compared. If the Mars first idea ever graduates from bedtime wonder to something sturdier, it will be because of that third category. Not because we found one dramatic ruin, but because many small consistent clues lined up like beads on a string. And the way we sharpen the question is simple, though not easy. We go where the surface can't lie as easily. We drill, not a few centimetres, not even a metre, but deep enough to get below the radiation-damaged layer. We bring samples back to Earth, where entire laboratories can interrogate them with instruments too large and delicate to ride on a rover. We explore the subsurface, radar that can see layering, gravimetric surveys that hint at voids, cave skylights that open into lava tubes, natural shelters that could preserve organics or artifacts or nothing at all. We look in the right places too, ancient shorelines, river deltas, sedimentary basins where fine layers settle gently, year after year, holding on to chemistry like a diary. Regions that were once warm and wet, and then sealed by volcanic ash or buried by dust. And we do one more thing, quietly, patiently. We tighten our definitions. Because if you don't know what you're looking for, everything starts to look like it. So the sober answer is this. Right now, we have Mars that once looked habitable, and we have Earth that preserves a strong, though incomplete, story of humans arising here. We do not have a Martian wrench. We do not have a Martian brick. We do not have a clear industrial scar across a Martian landscape, but we also haven't turned over many stones in the deep sense. We've skimmed the surface of a world that might keep its oldest secrets underground, the way a person keeps their hardest memories behind calm eyes. So the question stays alive, not as a claim, but as a kind of disciplined wonder. Not believe this, just if it were true, how would we know? And what would it mean to finally find something that isn't a symbol in the sky, but a fact in the dust? And even if we never find it, never find the wrench, the brick, the unmistakable scar, there's a reason the idea won't go away. Because it isn't only about Mars, it's about us sitting in the dark, listening to a planet breathe and wondering if the breath can stop. Picture it, a world that once had rivers, then didn't. A sky that once held warmth, then let it leak away. A place where the map of water looks like veins in an ancient hand. Mars doesn't just invite curiosity, it invites a very specific kind of fear. The fear that a home can become unhome without drama, without villainy, just through slow physics and bad luck and time. And when people imagine a Martian first attempt, what they're really doing is testing a thought they're almost afraid to say out loud. What if collapse is not a strange accident, but a normal chapter? We're drawn to the idea that humanity might have already failed once because it gives our anxiety a shape. Modern dread is often shapeless. It's graphs and predictions. It's headlines that don't end, just refresh. It's the feeling that something is shifting under your feet, but you can't point to the exact stone. A lost civilization on Mars turns that fog into a story. A clean narrative with a beginning, a peak, and a quiet end. And stories are how humans practice pain in advance. They let us hold a disaster at arm's length and still learn from it. They let us say, it happened there, while meaning, could it happen here? Because look at the list of things that haunt the present. Climate change, first of all. Not simply warming, but the whole complicated rearrangement. Droughts and floods, heat waves that feel like weather turning hostile, sea levels nudging at coastlines the way a patient tide nudges at sandcastles, seasons acting unfamiliar, like a friend who doesn't quite recognize you. Then collapse in all its forms, not just the cinematic version with fires in the streets, but the quiet one, systems that degrade, infrastructure that ages, trust that erodes, people doing fine until they're not, and then discovering the floor was thinner than they thought. Then migration, not the abstract kind, but the ancient kind. People leaving because staying stops making sense. Families carrying what they can, guided by rumours of water, work, safety. The oldest human story, written again and again, now scaled up by a warming world and crowded borders, and beyond all of it, planetary stewardship. A phrase that sounds polite until you sit with it. Stewardship means you're not the owner. It means you inherited something and you're expected to pass it on without ruining it. It means there will be someone after you, and their life will depend on what you decided was worth it. A Mars first scenario is basically stewardship turned into myth. It asks, what if we already lived through the consequences of treating a world as infinite? Maybe Mars didn't die because of smokestacks and plastic. Maybe it died because its magnetic field faded, because solar winds stripped the atmosphere, because the planet was smaller and cooled faster. Those are not moral failures, they're planetary facts, but that's part of why it hits so hard. Because if a habitable world can slip away for reasons that aren't personal, then our own world becomes even more precious, not safer, just more precious, like a candle you realise is the only light in a very large room. And if, in the thought experiment, a civilization did contribute to its own downfall, by overusing water, by cutting down what little grew, by burning what should have been saved, then it becomes a mirror that doesn't blink, not a scolding mirror, a calm one. It says, you can be intelligent and still be short-sighted. You can build cathedrals and still poison your river. You can map the stars and still forget that you need soil. Picture the largest city on Earth again. Not Georgian London this time. Pick your own. Fill it with glass and screens and delivery trucks. Now imagine the power goes out, not for a night, but for months. Imagine the supermarket shelves staying empty long enough that people stop assuming they'll be filled. Imagine the water pressure dropping. Imagine the invisible systems that make modern life feel effortless, suddenly asking to be maintained by hands that are hungry. It's not that we want this to happen, it's that we sense quietly how much of civilization is a thin agreement with nature. Stable temperatures, predictable rain, crops growing where we expect them to, oceans absorbing heat without flipping into chaos, a biosphere that keeps doing its job while we argue about ours. The Mars first story matters even if it remains unproven, because it reframes civilization as something that can be lost without being conquered. Not by barbarians at the gate, by arithmetic, by cumulative damage, by a few degrees, a few inches, a few missed seasons. By the slow turning of manageable into permanent. And there's another reason it sticks. It gives us a strange kind of hope. Because if Earth was a second attempt, if we imagine that some remnant crossed the dark and started over, then our existence becomes an act of recovery, a restart, a stubborn continuation. That's comforting in the way a lullaby is comforting, not because it denies danger, but because it insists on endurance. It suggests that even after failure, intelligence can try again. That memory can become wisdom instead of only grief. That the species can learn to live with limits. Of course, real history is messy and doesn't owe us symbolism. The evidence we have points strongly toward an earthly human story, not refugees from a red planet. But thought experiments aren't only about what happened. They're about what we're afraid might happen. And Mars, sitting there in the night sky, lets us ask the question, without flinching, what would we do if we had to start over? What would we save? What would we teach first? Fire, farming, laws, medicine, the idea that truth matters, the idea that the future matters? Because underneath all the science, underneath the rovers and the isotope ratios, the Mars first story is a way of asking whether we deserve the world we're standing on. Not in a religious sense, in a practical one. Are we acting like people who understand how rare stability is? And here's the final image to carry with you as the section closes. Imagine Earth as a house at night, seen from far away. One warm window in a black neighbourhood. Inside everything we've ever done. Every language, every love story, every war, every cure, every song hummed under breath. Now imagine that house is not something we built from scratch. Imagine it's something we found. An inheritance, a refuge, a second chance under a different sky. And the question becomes simple enough to fall asleep to and heavy enough to stay with you in the morning. If this really is the second attempt, what kind of caretakers will we be this time? Maybe that's the softest place to leave it. Not with proof, not with debunking, but with possibility held at the right distance. Because the compelling parts of the Mars first story are easy to name. Mars really did have water long ago. It really is a planet that seems to have changed its mind about being friendly. And it really does sit there like a reminder that habitability isn't a personality trait. It's a condition, and conditions can end. The uncertainties are just as real. We don't have a ruin you can point to and say, there, a door frame. We don't have a clear chemical signature that only industry makes. We don't have a Martian library waiting under a dune with a plaque in a language that somehow resembles our own. We have hints and gaps and a sky that keeps its secrets. So if you let this be a bedtime history, the kind you don't have to defend in the morning, it becomes something simpler, a meditation on second chances. If Mars was the first civilization in this thought experiment, then Earth is where the survivors learned what mattered. Not the monuments, not the flags, not the argument about who was right. The basics: water that stays water, soil that stays alive, a sky that holds onto its warmth, communities that don't waste their resilience on vanity, a memory of loss that turns into caution instead of bitterness. And maybe that's why the idea feels so human, because even in our real history, firmly, stubbornly earthbound, we keep doing this. We lose cities, we lose languages, we lose whole ways of life. And then someone somewhere plants again, teaches again, builds again. Not because they're certain it will work, because they can't help trying. So tonight, as you listen, you can imagine two worlds like two drafts of the same sentence. One crossed out, one rewritten, same intention. Better luck, a different sky. If this story held your hand for a while, take a second to like the video and subscribe if you'd like more quiet history to fall asleep to. And I'd love to know, where are you listening from tonight? Somewhere rainy, somewhere warm, somewhere far from Mars under the only sky we've got.